Okay, so in this video, we're going to take a look at how to perform operations with complex numbers. So we're going to be adding, subtracting, multiplying, and dividing complex numbers. So you do need to know a little bit about the imaginary number I before doing this video, just so you know, okay? But really all you should take away is that I is the square root of negative 1. So I know up to this point, we generally haven't been able to take the square root of negative numbers. That's just been kind of a no-go. But with the introduction of our imaginary number I, we actually can take the square root of negative numbers, and imaginary numbers are actually very, very useful in certain realms of computer science, as well as certain engineering fields that use differential equations, as well as quantum mechanics and nuclear engineering as well. Okay, so it is actually fairly useful. Okay, so with complex numbers, one thing that you need to know, one thing that you definitely need to know is that the standard form of a complex number is a plus bi, where a is considered the real part of the complex number and bi is considered the imaginary part of the complex number. So for example, like let's say we had a complex number like negative 2 plus 3i. The real part would be considered the negative 2, and the imaginary part would be considered the 3i, okay? Now, adding and subtracting complex numbers is actually fairly straightforward. It's basically the exact same as combining, as adding and subtracting polynomials. You essentially just combine like terms. You perform the operation and combine like terms, okay? So, for example, let's say we had, let's say 3 plus 4i, that's one complex number, plus the complex number negative 2 minus 5i. Well, all that we would do is we can combine like terms, and in this particular case, like terms are you're combining the real parts. The real parts are the like terms, and the imaginary parts are the other like terms. So we would have 3 plus negative 2, which would get us 1, and we'd have 4i plus negative 5i, which would be a negative 1i. And that's it. That would be your final answer, and it needs to be written just like this. The standard form of a complex number is always real part first, imaginary part second, so we want to have our real part first of 1 and our imaginary part second of negative I, okay? And that's really all that there is to adding complex numbers. Now, subtracting is also fairly straightforward. So let's say we had something like 5 minus 2i minus, let's say negative 6 plus I. Okay, so in this case, we're still going to essentially be combining like terms, so combining real parts and combining imaginary parts, except we're going to be subtracting them. So in this case, we're going to have 5 minus negative 6. Well, that double negative is going to turn into positive, so that'll be positive 11, and negative 2 minus I, or excuse me, negative 2i minus I, which would be negative 3i, and that's it. There's really not much more to it than that. Okay, so that's really adding and subtracting complex numbers. I don't think we need to go over too many examples of those. Okay, where things do get a little bit more interesting is when we start introducing multiplication and division. So let's say, for example, we had the complex number negative 3 minus 5i, and we are multiplying that by the complex number 5 minus 7i. Okay, so just like with multiplying two binomials, we would go ahead and double distribute what you might know as FOIL. We essentially just go ahead and FOIL the exact same way we would if it was just like 2x plus 1 times 3x minus 5. Okay, we just go ahead and distribute. So we could have negative 3 times 5 to get us negative 15. Negative 3 times negative 7i, which would become a positive 21i. And then we'd have negative 5i times 5 to get us negative 25i. And then we have negative 5 times negative 7i to get us a positive 35i squared. And this is where we need to take a step back for a second, okay? The standard form of complex numbers is a plus bi. There is no I squared. And that's because I squared is actually a real number, okay? If you think about it, if I is the square root of negative 1, if we were to square I, that would be negative, the square root of negative 1 squared. That would be the square root of negative 1 squared. Well, the square root and the square will cancel each other out, and that would just become negative 1. Okay, so I squared is negative 1, and that's extremely important to know, okay, because now wherever we see an I squared, we're simply going to substitute in a negative 1. So this is going to become negative 15. We can combine like terms here to become negative 4i plus 35i squared, and remember I squared is negative 1, so I'm going to substitute in negative 1 for I squared, and now I can continue to simplify. This is going to be negative 15 minus 4i, 35 times negative 1 is a negative 35, and this would become negative 50 minus 4i. And that would be our final answer for this multiplication problem, okay? So when you're multiplying, the only thing you need to be careful of is anytime you have an I squared, substitute in that negative 1 for I squared and simplify your answer in real part first, imaginary part second. Okay, so there's one more thing we need to take a look at, and that's when we have two complex numbers dividing one another, okay? So that would be something that would look something like this. If we had negative 5 minus 7i divided by 3 minus 4i. Now, this might not look like much, but this is actually a huge problem in mathematics, okay? Now, remember back in like Algebra 1 where you had stuff like 5 over the square root of 2, and you were taught that, hey, we can't have radicals on our denominator. Remember, I is the square root of negative 1, so technically, if we have an I in our denominator, we have a square root in our denominator. So we cannot have an I in our denominator. And to get rid of that, we use something that's called a conjugate, okay? You may have seen this a little bit with radicals in Algebra 1, maybe not, but we use what we call a conjugate, okay? Now, if we have a number a plus bi, its conjugate would simply be a minus bi, okay? All we do is we switch the sign of the imaginary part. And the neat thing is when we multiply two complex conjugates together, the imaginary parts actually cancel out and we're left with a positive real number, okay? And that's how we're going to have to get rid of our I in our denominator. So whenever we're dividing complex numbers, what we need to do is we need to multiply the numerator and denominator by our denominator's conjugate, okay? And the conjugate of 3 minus 4i would simply be 3 plus 4i. But we can't do something to the denominator without doing it to the numerator. So now I'm multiplying by 3 plus 4i to the numerator and denominator because I'm basically just multiplying by 1, okay? And the reason we're doing this is because now when I multiply this out, all the i's in my denominator are going to cancel, and you'll kind of see that in just a second. So I go ahead and I multiply, and remember, this is basically a multiplication problem, so we'd go ahead and distribute. We get negative 15 minus 20i minus 21i minus 28i squared. Remember, I squared is negative 1. And then in our denominator, we're going to have 9 plus 12i minus 12i minus 16i squared. And this is what is nice about multiplying by complex conjugates. See these i's here, 12i minus 12i? They're going to cancel each other out. And remember that I squared is equal to negative 1. So what's going to end up happening is all of the i's are going to cancel in our denominator, and we're going to have I squared that becomes negative 1. So we're just going to be left with a positive real number in our denominator, which we can have. Okay, so we go ahead and we continue to simplify. We get negative 15 minus 41i, and this would be minus 28 times I squared, which is negative 1, over 9, the 12 i's cancel, minus 16 I squared, which is also negative 1. And now when we go ahead and we clean this up, we're going to have negative 15. This is going to become a plus 28. So we're going to have negative 15 plus 28. Well, that's 13. So we have 13 minus 41i over, and remember, negative 16 times negative 1 is going to become a positive 16. So 9 plus 16 is 25, and this could be your final answer. Just know you can also split this up into two fractions, 13 over 25 minus 41i over 25. Both of these would be acceptable answers. And notice that we have a real part of 13 25ths and an imaginary part of negative 41i 25ths, okay? So that is operations with complex numbers. There's not that much to it. You just need to remember that I squared is negative 1, and whenever you're dividing, you multiply by the conjugate of your denominator. Okay, so that's operations with complex numbers. In future videos, we're going to be solving quadratic and polynomial equations. And now that we have talked about the imaginary number I, we can have solutions with I in our answer, okay? So make sure that we're keeping I in the back of our mind when we're solving equations in future videos. Make sure you check those out. Make sure that you practice.